In this lecture, we want to explore how copy constructors work with our inheritance hierarchies. And we will still be using the same example we have been using in this chapter. We will have this inheritance hierarchy, and we will still be using the same example we have been using in this chapter. The base class is going to be person. We're going to be inheriting from that publicly to create an engineer class. And we will be inheriting from the engineer class publicly to create the civil engineer class. And with this, we want to be able to copy construct objects. And the code we want to be running is something like this. We have an engineer object. We want to be able to create another object from this engineer object using the syntax here. And from what we already know, this is going to call our copy constructor. The funny thing is, this is going to work by default even if you don't put in your copy constructor. The reason is the compiler is going to insert a copy constructor for you, and things are going to be copied in a way that you expect because none of our classes is using dynamic memory allocation. So everything is just going to fall in place and it is going to work. But if you happen to need to set up your own copy constructor, we're going to see how you could do that in this lecture. And we're going to start by the base class. We're going to set up a copy constructor for the person class. And this is nothing complicated. We just pass our parameter by reference. This is going to be our source object. And we will be copying the data from our source object to initialize the member variables in the current object that we are copying here. Again, this is a copy constructor, which will be copy constructing from the parameter that we pass by reference. Now, how do we do the constructor for the engineer class, which happens to be inheriting from person? Try to think about that. One way to do things is to set up things like this, and this will be just initializing the engineer layer of our class, but nothing is going to be initializing the person part of us. And this is bad. This is going to call the default constructor to initialize the person part of us, and we will just be left in with junk data that is initializing the person object by default. And all the data we have in our parameter engineer object is just going to be lost for the person part of us. So we don't want to do this. This is bad design. You shouldn't do this. Some of you are going to say, but what if we call the base constructor? We have seen that we could do that, right? But remember, this is a copy constructor. What we have on the left is an object. And it happens to be that if you set up a syntax like this with the copy constructor, the compiler is going to set up a temporary person object and a copy from that object to initialize the person part of us. So this is going to be creating a temporary copy object containing the same data we have in our engineer object. So to some extent, this is going to work. But the problem we still have is that we are using the m-address member variable directly from an engineer object. And from what we already know, this m-address member variable is private to the person class, and we have no business accessing this from an engineer constructor. So this is going to give us a compiler error. But know that it is possible to set up a getter in the engineer class that is going to return this address, and you can call that getter here and get this thing to initialize your data. This is going to work, but this is really weird. You shouldn't do this. This is bad design. There is a better way. I am going to show you. But before we look at that way, let's try and summarize the problems we have with this way of doing things. This is not going to be reusing the copy constructor we have worked hard to set up in person. So this is just going to be code duplication. Another thing is that the m-address member variable is private to person. So if we try and use it like this, we're going to get a compiler error. Again, it is possible to set up a getter that could return that, and we could use that getter in this place. But this is bad design. We are really forced to set up a getter that is possibly only used in this place. That's bad design. We don't want to do something like this. Another thing is that this is going to create a temporary copy of person from which we will be copying to initialize the person part of us. We don't want to be making that copy because we hate copies in C++ code. So the best way to do this is to set up your copy constructor in this way. We are going to say person and directly pass in our engineer object. The compiler is smart enough to see that we are passing an engineer object to initialize a person object. And what the compiler is going to do is really smart. Suppose our engineer object is made up of two layers. The inner layer is going to be containing the information about the person part of us, and the outer layer is going to be containing the engineer part of us. Okay, so this is the setup we have. So the compiler is going to see that we are passing in an engineer object to initialize a person object, and what it is going to do is really smart. It is going to strip off all this engineer part. If I can describe it like this, we're going to strip off all this engineer part that we have in our engineer object, and we will be just left with the person part that we pass then to initialize our person object. And this is really smart, and it is going to work. So again, the syntax is what you see here. We say person, we pass in our source object, and then we can initialize the member variable that belong to the engineer part of us. We will be initializing contract count, and this is going to work. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is Copy Constructors with Inheritance. We will be reusing the code from the last lecture, so we're going to grab everything from that except for the binary. And we're going to copy that and put that in our current project. Let's do this. And we are going to open this bad boy in Visual Studio Code by dragging and dropping here. And we will have our starting point. We will have our person class, the engineer class, and the civil engineer class. And we will just be doing public inheritance to make things easier here. So engineer is going to publicly inherit from person, and civil engineer is going to publicly inherit from engineer. And this is everything we had from the last lecture, nothing special. But what we want is to set up copy constructors in such a way that we will be able to build objects from others. For example, if we leave in our engineer object, I think this is what we used in the slides, we're going to have our engineer1 object. We want to be able to create another engineer, let's say engineer2, and build that from engineer1. The thing that might be puzzling to some of you is that this is going to work out of the box, even if we didn't really put in a copy constructor. But the thing is, the compiler is going to insert a copy constructor for you, but that constructor is going to be member-wise copy. So it is basically going to be copying things member-wise. It is going to take the contract count from engineer1 and copy that into engineer2. And we are basically going to have the same data from engineer1 in engineer2. Let's try and print engineer2. Can do that. We're going to say eng2, and we're going to put this out. And we are going to run the task to build with GCC. That's what we want here. And you're going to see that it is going to work out of the box. If we bring up a PowerShell window and run Rooster, we're going to see that we have the data in here. We have engineer full name, Daniel Gray. That's the data we have in engineer1. But notice that we are printing engineer2 here. The age is going to be 41, and the address is going to be exactly what we had in engineer1. And you're going to see that the constructors are going to be called to set up engineer2, and the custom constructor for person is going to be called, the custom constructor for engineer is going to be called, and this is exactly what we expect here. But what if we want to set up our own copy constructor? And the need to do that might arise if we happen to be doing some dynamic memory allocation in our classes. Suppose maybe person class has some dynamic memory allocation, it has some pointer member variable, and in the person custom constructor, we are doing some dynamic memory allocation to initialize that pointer. We may be doing the same thing at the engineer level or the civil engineer level, and that will force you to set up your own copy constructor, and we're going to see how you could do that in your classes. We are going to start with the person class. We're going to go on top, and set up a copy constructor in front of our destructor here. We're going to say person, and we're going to say const person reference source. This is the syntax you use to set up your copy constructor. You already know this from a previous chapter, and we're going to put in the implementation for this. We're going to go in the CPP file before the destructor, or we should go after our custom constructor. It doesn't really matter where you put this. And we're going to put in our scope resolution operator. Let's do person here. And we will just be copying data from the source person. So we're going to put in our initializer list, and we're going to say m full name. We're going to grab the name from the source person. We're going to say source m full name. We're going to initialize the age. We're going to say m age, and we're going to grab the age from the source person. So m age here. And we can go to the next line so that we see the entire thing here and say m address, and we're going to say source and say m address. This is going to set up our constructor, and down below we can put in our body. This is going to work, but this is everything we have seen so far. This is nothing new. The syntax to set up your copy constructor, you just pass it by const reference. If you don't pass by reference here, you're going to get an endless chain of copy constructor calls. If this is confusing to you, please go back to the chapter on classes. You're going to see everything about this. And this is really all we need to do here to have a copy constructor for person. Now, let's do things at the engineer level. We're going to go to our engineer class, and we need to set up a copy constructor. The syntax is going to be the same. We're going to say engineer, and we will be constructing from a const engineer object we pass as a parameter here. So we're going to say const engineer by reference and say source. And the problem is going to be how we implement this thing. We're going to copy this and go in our engineer CPP file. We're going to put our copy constructor after our custom constructor. And we're going to put in our scope resolution operator. We're going to say engineer, and we're going to put in our body. Let's go below and put that in. If we do things like this, this is just going to initialize our engineer with junk data. We don't want that. But some of you might say, I don't know how to call my base constructor, but at least I can initialize my contract count. Okay, let's go back and see if we have this member variable here. Yes, it is called contract count. We can say contract count here, and we are going to initialize this with source contract count. This is going to work, but this is going to call the default constructor of person to initialize the person part of us. And let's go back in our main CPP file and see what we are using to try things out. We are building an engineer object from another. Let's try this out and see if our copy constructor is called here. So we're going to say custom copy constructor called for engineer. We're going to put in the message, and we're going to say custom copy constructor, and we're going to build our code. Let's build. We're going to pass this through GCC to see what happens. The build is going to be good, and let's see what happens. We're going to clear and run roster. We are going to see that the constructors are going to be called to set up person one, but we see that the copy constructor for engineer is called. And what I want to do to really make this super clear is put a separator between these two guys. To really know what is happening here, I am going to put in a bunch of dashes just like this. I am going to put in my new line character, and I am going to build again. The build is going to be good. As you see here, we can clear and run roster. Now we are going to see that the default constructor for person was called to set up the person part of us in our engineer copy constructor. And the reason is we are not doing anything to call the custom copy constructor from person. And let's go back in person and make sure we are printing proper information to really see this. When we get to do this right, we are not putting in any method here. So we should do that. We are going to say custom constructor or custom copy constructor called for person, but this is not called. You see that we are calling the default constructor, and this is going to initialize our person part with junk data. If we print engineer2 here, you're going to see that the full name is none, the age is 0, and the address is none. So we are basically getting the default data we have in our person object. Let's go back and really show you that. The default full name is going to be none. The default address is going to be none. The age is going to be 0 by default. And this is what we get because in our copy constructor, we're not doing anything to get our custom constructor in person to be called. Okay, so this is not going to work. This is bad. We don't want to do something like this. But let's comment this out and show you another way we might try to do things. And we are going to copy our copy constructor. Let's go down and do this. We're going to put in another copy of this, but we don't want to just initialize our contract count member variable. Instead, we want to do something else. We're going to put a comma here. And we're going to say person. Some of you might be thinking, what if we call the base constructor directly? We can do something like this. We can say person and we can say source m full name. We can do that. We can say source m age. And some of you are going to say source m address. Let's do that. Source m address. And we're going to build a person object and use that to initialize the person part of us. We are basically going to be calling the other person constructor that we have, which takes 3 parameters. This constructor here, this is what we are trying to call in our copy constructor. But as we saw in the slides, this is going to have a bunch of problems. This is going to be creating a temporary person object that we are going to be copying from to set up the person part of us. But another problem we have, which is actually going to cause a compiler error, is that we don't have access to the m address member variable from an engineer constructor. And this is going to give us a compiler error. Let's actually try and compile this program to really show you this. We are learning. We should really see as many compiler errors as we can. So the build is finished with errors, and if we go up, we're going to see that our error is the m address member variable is private to the person class, and we have no business accessing that in the engineer CPP file at line 27 in our constructor here. And this is going to be our offending line. We can't do this. One could go in our person class and set up a public getter method, which is going to be inherited by engineer. And we could call that to return the address. Let's actually do that to show you that you can do that. So we are going to go in and put in a public method, which is going to return the address. We actually have that here. So we can call that. We can say source get address. This is going to work. This is going to set up our thing. Let's try to build because I think Visual Studio Code is messing with us here. Okay, you see the build is good. It is Visual Studio Code, which wasn't understanding our code here. And if we run our program, we're going to see that things are going to work exactly as we expect. Let's actually run the program here. We're going to clear and run rooster. We're going to see that now the information is being forwarded properly, but we are setting up a temporary person copy, which we are copying from to then forward the data to the person part of us. This is not good design. And what we really want is the setup that is going to allow us to call the copy constructor that we worked hard to set up in our base class here. Let's go back to person and see that. If we go up, we're going to see that we have a copy constructor we really worked hard to set up. We want to reuse this in our engineer class. And that's what we're going to see here. So this is working, but it is not optimal. And we should really try to reuse our code as much as we can. So what we're going to do is set up a mechanism that is going to reuse the copy constructor we have in person. And all we need to do to get that to work, we can say person and then call the copy constructor of person by directly passing in our source object. Notice that we don't need to set up a temporary person object. We will directly be copying from our engineer object, but this is going to do the slicing we saw in the slides. Again, if we have 2 layers on our object, the inner layer is going to be the person part of us, and the outer green layer is going to be the engineer part of us. What the compiler is going to do, the compiler is going to see that we are actually passing in an engineer object to initialize the person part of us here. And it is going to see that we just need the red part, we don't need the green part here. The compiler is really smart, so it is going to slice off the outer engineer layer and only leave in the green person part, and it is going to use that to initialize the person part of our engineer object. And this will be reusing the copy constructor we have in our person object. And this is really cool. This is the optimal way to set up your copy constructors if you have an inheritance hierarchy. So let's try and build the code again. We're going to pass this through GCC to see if this actually works. The build is going to be good. We can clear and run rooster. We're going to see that the copy constructor is going to be called for person to set up the person part of us. And then the custom copy constructor for engineer is going to be called to set up the engineer part of us. And if we look at the information we have in the main function, we're going to see that it is the same data, Daniel Gray for the full name, age is 41, address is this gibberish here, and the contract count is 12. It is exactly what we passed here, and our copy constructor is working. Now that we have this working, we can safely reuse the same ideas in our civil engineer copy constructor. We can head over in our civil engineer and set up a copy constructor. So let's do that. We can close the left sidebar here so that we see the entire thing. We are going to say civil engineer, and we want to set up a copy constructor. So we're going to say const civil engineer here, and we will be passing this by reference. We're going to say source, and we're going to put the implementation of this in our CPP file. We can hop over there and go below our custom constructor. We can put in our constructor here. We're going to say civil engineer and put in our scope resolution operator. And we're going to go down and put in the body. And in our initializer list, we're going to call the copy constructor from engineer, because remember, civil engineer is inheriting from the engineer class. So we are going to call the engineer copy constructor. We're going to pass in source. And again, this is going to slice off the civil engineer part and only use the engineer part of us to construct an engineer object from this sliced off engineer object we get from our copy constructor here. And this is really cool. After that, we will initialize our contract count member variable. Oh, it is M speciality if I remember correctly. And we're going to grab source M speciality, and we will use that to initialize the civil engineer part of us here. Let's go in and say that the custom copy constructor is being called here. And we're going to say custom copy constructor called for a civil engineer. What did we do here? We said engineer. Let's do engineer. This is what we want. And we're going to say engineer here properly. Sorry for this, but this is no big deal. And now that we have this in place, we can actually build civil engineer objects and copy construct them. We can comment out the engineer stuff we have, and we can just put this in a block comment. And we're going to copy construct civil engineers. How cool is that? We're going to set up a civil engineer. Let's do that. And this is going to be a civil engineer. And we're going to say Daniel Gray. We're going to put in all the data, and we're going to specify the speciality to be road strength. This is something I just made up. I don't even know if this kind of speciality exists. And we will set up another civil engineer object called ang2, which we are going to be copy constructing from. And we will see what happens when we copy construct this thing here. We should call our copy constructor in civil engineer, and things should propagate up all the way to the person part of us, and we're going to see what happens. Let's build this code. We're going to pass this through GCC as we always do. The build is going to be good, so this is good news. We're going to clear and run rooster. And we're going to see that the custom copy constructor is called for person. The custom copy constructor is going to be called for engineer. And the custom copy constructor is going to be called for civil engineer. And you see that things are really propagating all the way to the person part. And we are calling and reusing our copy constructors. And this is really cool. If you go down, you're going to see that the information is printed out correctly. The full name is Daniel Gray, which we have in engineer 1. The age is 41. The address is all this gibberish. The contract count is 12. And the speciality is road strength. And we are properly reusing our copy constructors in our inheritance hierarchy. This is really all I had to share in this lecture. Again, the syntax you should be using to set up your copy constructors is what we see here. This is going to be reusing the code we have in our upper classes in our hierarchy. We will be avoiding the temporary copies we saw when we called the other constructor directly. And this is much cleaner. It is reusing code we have in other classes. We are going to stop here in this lecture. In the next one, we're going to see that it is actually possible to inherit base constructors. Go ahead and finish up here and meet me there.